Okay, so local minimums and maximums. The key here is that we have these local minimums and maximums. I put these as points, all right? So we've got a local minimum and a local maximum as a point. Now you can have lots of local minimums and lots of maximums. So a local maximum is just the top of a hill. It's not the top of a mountain, the highest point on earth. It's just the top of the hill, highest point around. And then our local minimum is the bottom of a valley. It's the bottom, the lowest point around. Our arrows cannot be local minimums and maximums because they don't go back up or back down, right? Local minimums and maximums are really turning points, right? They're a spot where it turns and changes from increasing to decreasing or decreasing to increasing, okay? And our increasing and decreasing intervals are written as x is greater than, x is less than, or x is in between, right? And they're all about x values. So when you're writing the answers to these, your y values are going to just be in your local minimums and maximums, but then we have our x values here. Okay, let's look at one. So the key here is that we have to use our graphing calculator, and that can be actually the hardest part of this whole process. So we're going to take this function, and we're going to plug in x cubed minus 3x squared plus 6. Now, as I said, this is the hardest part, so you have to be trying it along with me, and you have to practice it. You're going to have mistakes that happen, okay? And that's okay. We'll work through those. So this is the basic shape of it. Okay, so I'm gonna give just a little sketch. We don't know the exact pieces yet, but give us just a little bit of a sketch there. Okay, now if I look, the first thing I'm gonna do is to identify our x-intercepts, okay? So to find our x-intercepts, I'm going to write down over here what kind of our process is as I do it. Okay, so we've graphed it. You're going to hit the second trace or get to the calc button. Okay. Then we're looking for the x-intercept. Another name for x-intercept is 0. Now, the idea here is that we want a snapshot. We just want to zone in and tell the calculator, just look in between these two pieces. Just look at that one spot right there. Okay, so if you look, it should say the question left bound question mark. So we need to go to the left side of the value that we're looking at. That's the value that I'm looking at. And then hit enter, and then use our left and right, and we're using left and right arrows. Even though we're going up and down, we're also going left and right, and you want to go to the right side of it. It says guess. You can just hit enter, and it will give you a 0. Okay, so just recap. We have to create our left bound, create our right bound, and then do our guess. And after each one of these, you're going to hit enter. All right, and here we're going to use our left and right arrows. Okay, so in this case, it should give me a y as 0 and an x, and I'm going to do 3 decimal places for right now. Now, if you get a y that has something like e to the -6 or something, that's close enough to 0. All right, your calculator, that's scientific notation, and it's close enough to 0. Okay, so that's what this point is right here. The points where I have local minimums and maximums. So if I look at it, I can see this is going to be a local max. So I have to figure out what that value is. So hit second trace again, do the exact same thing. This time though, we're going to go down to maximum instead of a 0. So you're going to go to the maximum. Again, we're going to do our left and our right bound. So left bound, again, this is the point. So I'm going to go to the left side, to the right side, hit enter. Okay, notice that this gave me, if you can see on there, it gives me like an E to the something that's close enough to 0. So my local max is at 0, 6. Now I want to find this local min down here. So do the same process, second trace to get to the calc. Minimum, go to the left side of the bottom part to the right side. You can see sometimes I get closer than others. You just can't, you have to only have this one spot, all right? You can't have lots of bumps. You want to give it enough spot that you know what it's looking for, or it knows what it's looking for. So then our local min is at the point 2, 2. Right? If I round that out, that becomes just 2, 2. Okay, so those give us all of the different points. Make sure that you can do that on your calculator. Now we have to do the intervals where it's increasing and where it's decreasing. So let's look at that. Let's look at where it is increasing first. And we look and we can see it's all the way along here. Now I like to think of this like an Algebra 1 problem, right? Where if I was given something here, I have an open circle and going to the left. So this is it happens to be at 0. So I'm going to say that x is less than 0. It's also increasing from here over. So starting at this spot and going over. So it's also increasing at x is greater than 2. Now remember from Algebra 1, this is called an OR problem. X is less than 0 or x is greater than 2. We also in Algebra 1 had what we considered AND problems, which were right in between. Right, when we had something in between like that. So that was what we called an AND problem, because we would say that x is in between 0 and 2. So x is greater than 0, but it's also less than 2. Now, just as a reminder, our increasing and decreasing, we look from left to right. Okay, so think about riding a roller coaster from left to right. Start over here. What am I doing? I'm going up, then I go down, then I go up. Okay, what I would like for you guys to do right now is I want you to work on part B. And you can work with someone right at your table because there's a lot of pieces here, right? It's an x to the 4th problem. There should be 4, and there are going to be 4 x values. Ooh, wait. This was x to the 3rd. Why was there only 1? That's because there are 2 imaginary solutions there. Okay, so we don't have to find those anymore, not for this problem at least. So there are going to be 4 x values. There are going to be a bunch of local mins and maxes. So I want you guys to try that on your own, and then you guys can check back here at the solution. Again, if you want to work with someone right next to you so that you don't have to hit these buttons a million times, you can do that, and then help each other out.